Hello everyone. So I've been a bit busy these 3 weeks or so I could not upload any content. So today we are going to look at problem number 21 in Leetcode, merge to sorted lists. As you can see, this is an easy problem. So you are given two sorted lists. You have to basically merge them and return it as a new list. The new list should be made by splicing together the nodes of the first two lists. So given this example, you see that input consists of two lists, 1 2 4 and 1 3 4, and in the output you see that 1 1 2 3 4 4 is given, right? So how would you solve this problem intuitively? Let's take these two lists. Okay, so given these two lists, how will you solve this intuitively? So let's consider the first one and this first one. Now 1 and 1 are basically equal, so if they are less than or equal, then we can just add 1 to the merged list, right? And so let's consider that we have taken 1 from the first list. In this case, we have to move to the next entry, right? And then 2 and 1 we will compare, and we will add 1 from the second list. Okay, and note that we need to keep a pointer to this previous entry, because whenever we are adding, we should basically add or we are basically appending to the existing entity. Okay, so now we'll add 1 and then we see 2 and 3. Out of 2 and 3 we see 2 is smaller, so which means to this previous we will add 2 and so on. Okay, and then 3 we will add, and then we'll add 4, and by the time we come to 4 of this list, we see that this has become null. So in this case, basically whatever is there at the end of the second list has to be added. So what I'm trying to say is, suppose let's say 5 and 6 is there, so by 4, when we reach 4 at the first list, we would have exhausted this first list, which means whatever is there towards the right of this will be added to this particular list, because we have already done the sorting. The remaining are definitely going to be greater. Okay, so this intuition basically is the iterative version. Okay, so we are going to maintain a pseudo previous just for easy manipulation. So what I'm going to do is, I'm going to initialize list node pseudo result. Okay, pseudo result. So this is going to be a new list node initialized to -1. I'm making use of this constructor. Okay, so what we will do is, let's use this pseudo result, and finally we will append every entry to this pseudo result. Basically this is a result, only thing is it will just have -1 as a node in front. And so finally what we need to return is pseudo result dot next. Okay, so so this is basically to keep track of the head entry, right? So now we need to consider how are we adding entries. So when you have 1 2 and 3, and then you have 1, right, 4 and 5, and when you're merging it, you basically need to keep track of what is the previous entry. So let's say 1 is already there, we need to add this one to this list, so we need to make a note of what is this location, and then to this we will be adding 1. So basically we need to track of this previous pointer as well. So for that, I'm going to say previous node. So initially this will be pointing to pseudo result, because this is our head currently, right? So what we're going to do is, so we've given two lists L1, so L1 is not equal to null, and then L2 is not equal to null. So in this case, what we need to see is, out of these two, we considered 1 and 1, and we basically compared which is smaller, and then we added to the list. So basically we have to see if L1 dot val, if it is less than or equal to L2 dot val, right? If they are equal, then we have to consider any one of them, right? So in this case, what I'm going to say is previous node, which is currently pointing to -1, its next is going to be L1. Okay, now we have added 1, so now we have to increment L1, not increment, actually make L1 point to the next node, so L1 dot next. Okay, and for the else case, what you have to do is previous node, this means L2 is smaller, right? So previous node dot next is going to be L2, and L2 is equal to L2 dot next. Okay, so now this condition is basically for comparing 1 and 1, and then we have added 1. Okay, now we need to for the next comparison we will be having 2 and 1, so we need to add this particular 1 to this one, right? This is the result. So here we need to move our previous node as well. So now previous node is what? -1, and to that -1 we have added the new one, right? And then to this one we need to add the next one, so which means we need to increment previous node. So previous node equal to previous node dot next. Okay, now if at all, if you've got any big list, let's say 1 2 3 and then we have got 1 2 4 5 6 and 7 and so on, so by the time we compare 3 with 4, right, so this list would have already got exhausted, so which means we have to just append whatever is there to this list, to the merged list. So what we will do, we will compare 1 and 1, we'll add 1, and then we will compare 2 and 1, we'll add 1, and then we'll compare 2 and 4 and we will add 2, right? And then we'll compare 3 and 4 and we will add 3, and then we see that, you know, the first list is exhausted, right? In which case we have to just go ahead and add whatever is there in the second list. So we need to add 4 5 6 and 7. Okay, so for that what we will do is, so now previous node dot next, right, equal to, we'll basically check if L1 equal to null. If L1 equal to null, then we have to just append L2, otherwise we have to just append L1. Okay, so that is how it is. I hope the logic was clear. And so when you compare the time complexity, and you can see, as you can see, this is a iterative version, right? So depending upon the length of the bigger list, it is going to be O of, let's say, or the first list is smaller, then in this case it is the bigger list will basically determine the complexity. So given two lists of size n1 comma n2, we can say the complexity, overall complexity, right, the time complexity is going to be O of n1 plus n2, where n1 and n2 are nothing but the sizes of the list. Now what is the space complexity? So we are not actually using any space at all, we are just using some variables, right, to basically keep track of which is the previous one, and basically keeping track of the pseudo head and so on. So the space complexity is actually O of 1. Okay, so let's go ahead and run this code. It's accepted, let's submit it, and it's a successful submission. And as you can see, this is 0 ms, which is faster than 100%. Okay, so I hope it was clear. Let me know in the comments if something is not clear. So bye guys.